Hello, and welcome to the Sleepy Signals. Tonight, I invite you to set aside the noise of the day and join me on a gentle journey backward through time, far beyond the stories we usually tell about the past. We will drift back to an Earth that looked nothing like the one outside your window, back before the great forests, before the thunder of dinosaurs, even before the air itself was safe to breathe. Tonight, we wander toward the very first signals of life, carried to us through stone and silence. This is not a hurried lecture. It is a slow unfolding, designed to soothe your thoughts, calm your body, and perhaps, if you let it, carry you into sleep while still leaving you with the quiet wonder of knowing you have touched something ancient. Maybe you are listening in bed, your head sinking into a pillow that feels just right, the light already dim, your phone resting on the sheets. Maybe the world outside is quiet for the first time all day. Some of you might be hearing this in the middle of the night, others in the early hours before the sun. Wherever you are, whether it is a midnight in Manchester or a soft dawn in Melbourne, you are welcome here. You are part of a circle that stretches across the globe, each listener resting in their own corner of the night. There is something comforting about that, isn't there? To know that while you lie there, eyes heavy, thousands of others are listening to the same gentle story, sharing the same quiet moment. And in that moment, I ask you to breathe. Slowly, deeply, with no urgency. Feel the way your chest rises, the way air slips into your body, the way it leaves again. It's so natural, so constant, that we rarely think about it. Yet even this simple breath carries echoes of life that began billions of years ago. Every inhale is filled with oxygen that was not always here. Every exhale carries carbon, the same element that once drifted through ancient oceans before it was gathered into cells. That breath ties you to the oldest stories of Earth, whether you are awake enough to reflect on them or already floating closer to sleep. The story of fossils is, in one sense, the story of memory. They are whispers pressed into stone, fragments of voices that would otherwise be lost forever. They remind us that life has been here for far longer than our minds can easily hold, stretching back through ages so immense they make our own years feel like fleeting sparks. When you hold a fossil in your hand, or even just imagine one, you are holding a signal from deep time, a message that traveled billions of mornings and nights to reach you. Doesn't that give you a sense of awe, but also of peace? To know that everything we are was shaped by a chain of life so persistent that it survived unimaginable challenges just so you could be here now. Before we sink into the details, let's linger for a moment on the sheer strangeness of this idea. We know the world by our memories and our stories. But what about a time before memory, before story? What about a time when the Earth was raw, molten, dangerous, and yet somehow preparing to give birth to something as delicate as life? The contrast is almost too much to grasp. A world of chaos, storms, and fire, yet out of that violence came the first sparks that would eventually become you, me, and every living thing we see today. Doesn't it stir something inside you to realize that even in the most hostile conditions, possibility was quietly forming? Perhaps as you listen, part of your mind is wondering, how do we know any of this? How can we even glimpse the lives of creatures that existed before bones, before shells, before anything recognizable as an animal? That is part of the mystery that makes this journey so soothing. We cannot rely on photographs or memories. Instead, we must listen to the faintest traces, the chemical signals embedded in rocks, The shapes of microbial mats, the layers of sediment that were laid down like pages in an endless book. Fossils are not just bones of dinosaurs or leaves pressed into stone. They are also the tiniest imprints of bacteria, the subtle patterns left behind by organisms too small to see, yet powerful enough to change the course of a planet. I want you to feel how extraordinary that is. When you think of fossils, maybe you picture a trilobite or the skeleton of A.T. Rex looming in a museum. But imagine instead a whisper so quiet you could almost miss it. A layer of rock that once held a mat of microbes, hardened by time into a ripple that still carries their presence. It is not dramatic, but it is profound. Those ripples tell us that life was there, billions of years ago, doing its quiet work. And here we are, so many ages later, able to notice. That connection alone can calm the restless mind. Life leaves marks, and those marks endure. As we begin this story, I encourage you not to hold on too tightly. You don't need to remember every date or every name. This isn't about memorizing a timeline. It's about letting yourself be carried by the current of deep time, floating gently as the narrative unfolds. If your eyes close, that's fine. If your thoughts drift to something else, that too is fine. The story will still be here, patiently waiting for you, just as fossils waited for millions of years to be found. Think of this as both an invitation and a reminder. An invitation to curiosity, because who wouldn't want to know how life began? But also a reminder that you don't need to force yourself to stay awake. The beauty of this journey is that it serves you either way. If you stay with me, you'll travel further and further back, meeting the earliest forms of life. If you drift off, your mind will carry the rhythm of the story into your dreams. Either way, you're part of something much larger than yourself. And isn't that the most reassuring thought of all? That no matter how fleeting our lives feel, we are rooted in something vast, something ancient. You are a moment in a chain that stretches back to the very first breath, the first cell, the first spark. You are the newest chapter in a story that has never stopped unfolding. That is what fossils whisper to us and why they matter. They are signals from the deep past, waiting quietly until someone like you is ready to listen. So let us take the first step into this ancient silence together. Before the forests, before the dinosaurs, before the air itself was safe, there was life beginning. Fragile, persistent, improbable. And as we explore it, let yourself settle in. The night is long. The story is patient. And somewhere within it, you may just find the comfort you've been searching for. Close your eyes for a moment and try to imagine an Earth so unfamiliar that it would feel almost alien. The skies above are heavy with volcanic ash, streaked with lightning that cracks across a horizon the color of rust. Oceans stretch out in endless darkness, swirling with minerals and chemicals rather than fish or seaweed. The air is thick, hot, and suffocating, filled with gases that would burn your lungs in a single breath. There are no trees, no grass, not even the simplest flower. Just a raw, restless planet, violent and untamed, waiting for something to happen. Can you picture it? It feels lonely, doesn't it? As if the earth itself is holding its breath, preparing for a story that hasn't begun yet. And yet, within that loneliness there is potential. Every storm, every wave, every spark of lightning was stirring ingredients together like a cosmic recipe, though no one was there to witness it. Imagine a pot simmering on the world's largest stove, the ocean acting as the broth, and into it falling carbon, hydrogen, nitrogen, and sulfur, simple elements mixing again and again in a restless dance. For millions of years, nothing recognizable came from it. But eventually, something changed. Molecules began to connect, forming more complex shapes, like tiny Lego pieces snapping together by chance. These shapes were fragile, easy to break apart, but every so often one held together a little longer. And that is how possibility began to take root, not with a bang but with a whisper, not with certainty but with chance. Scientists call one version of this idea the primordial soup, a poetic name for oceans brimming with chemical ingredients. In this vision, lightning or ultraviolet light struck the soup and nudged molecules into forming amino acids, the building blocks of proteins. Picture a storm raging over an ancient sea, each flash of lightning like a cosmic match striking again and again, hoping to light a fire. Most sparks die instantly, but one spark lingers, and from it comes the faintest flame of life. Isn't it humbling to think that everything you know, every bird, every tree, every human, might trace its ancestry back to a single flash of lightning in a chemical ocean? It is almost absurd, and yet profoundly beautiful. But that isn't the only possibility. Another theory points us not to the surface, but to the depths of the ocean, where hydrothermal vents spew hot, mineral-rich water into the surrounding sea. Even today, these vents are surrounded by strange ecosystems, full of creatures that thrive in darkness and heat. Perhaps it was here, in the cracks of the seafloor, that the right conditions came together. Minerals formed natural chambers, like tiny test tubes, protecting fragile molecules and allowing them to connect into chains of information. Imagine a chimney at the bottom of the sea, breathing warmth into the water, its mineral walls acting as both shelter and laboratory. From that hidden furnace, the first whispers of life might have risen, sheltered from the chaos above. And then there is an even stranger idea, that life's ingredients didn't start here at all. Maybe they arrived from space, carried on comets or meteorites that slammed into the young Earth. This is the panspermia hypothesis, the suggestion that we are, in a sense, children of the stars in more ways than one. It is not as far-fetched as it sounds. Scientists have found amino acids in meteorites, proof that the building blocks of life can form beyond Earth. So perhaps our story began with a delivery from the heavens, a cosmic seed carried across light years and planted in the fertile chaos of an early ocean. If that is true, then our origins are even grander. Life is not just an earthly accident. It is part of a wider, universal pattern. Doesn't that spark a deeper question? If life could begin here after such a journey, could it also exist somewhere else, even now? No matter which theory you prefer, the soup, the vents, or the cosmic gift, the truth is that something remarkable happened. Simple molecules, nothing more than clusters of atoms, became self-replicating. They began to copy themselves, however imperfectly, and in those imperfections new possibilities were born. Out of chemistry, biology emerged. Out of chance, persistence. Can you feel the shift? A planet that once only boiled and burned now carried the seeds of something that could grow, change, and adapt. Life's first spark was like a match struck in a storm. Against all odds, it stayed lit. It's worth pausing to notice the fragility of that moment. Think of all the things that could have gone wrong. A different chemical balance, a harsher storm, a slightly cooler ocean, and perhaps that flame would have never caught. In that sense, our very existence is balanced on an edge of luck so narrow it almost feels impossible. And yet here we are, billions of years later, breathing air that life itself created, thinking thoughts that life itself made possible. Doesn't that fill you with a sense of both wonder and gratitude? To know that your life is the continuation of that first fragile experiment, that you are the latest verse in a poem the earth has been writing since its earliest dawn? The mystery, of course, is that we still don't know for certain how it began. The soup, the vents, the stars, they may each hold part of the truth. Scientists continue to search, experimenting in labs, analyzing ancient rocks, sending probes into space. But perhaps the lack of certainty is part of what makes the story so soothing. It leaves room for imagination, for curiosity. Was life inevitable, as natural a consequence of chemistry as rain is of clouds? Or was it a cosmic accident, a one-time miracle never to be repeated? Which thought feels more comforting to you, that life will always find a way, or that our existence is an unrepeatable treasure? As you turn these questions over, let them wash through you gently rather than demand answers. This story isn't about solving the riddle in one sitting. It's about resting in the mystery, letting the vastness of time quiet your worries about tomorrow. If life could emerge in such hostile beginnings, doesn't it remind you that growth is possible even in your most difficult moments? That new chapters can emerge from chaos, and that resilience can be born from fragility? The earth itself is proof. So as the night deepens around you, picture that early planet once more. Picture a stormy ocean glowing faintly under lightning, or a vent in the dark depths exhaling warmth, or a meteor tumbling through space carrying a gift it does not even know it bears. From any of these beginnings, life found a foothold. And from that foothold, everything else followed. Tonight, as you listen, you are part of that lineage. You are not separate from the story. You are its latest chapter, breathing proof that a fragile spark, once kindled, can burn across billions of years. When we talk about fossils, most people picture dinosaur skeletons, shells pressed into stone, or perhaps a fern delicately outlined in rock. Those images are familiar, almost comforting in their clarity. But the truth is that fossils are not limited to bones and leaves. They're far more varied, far more subtle, and far more ancient than most of us realize. A fossil, at its heart, is any trace of life that has been preserved across time. It can be an imprint, a body, a chemical residue, even the faintest pattern in stone that whispers, "Something lived here." That simple idea changes everything, doesn't it? Suddenly, fossils are not just museum pieces, but the Earth's memory, a record book written in minerals, holding on to stories long after the storytellers themselves have vanished. Imagine holding such a memory in your hands. The stone feels cool, ordinary at first, no different from any rock you might kick along a path. But look closer. There, across its surface, are faint ridges, layered like ripples on water. They're not random. They're the remnants of living mats of bacteria that grew and layered upon themselves billions of years ago. These are stromatolites, some of the oldest evidence of life. We have structures formed around 3.5 billion years in the past. That number is so large that the mind struggles to grasp it. 3.5 billion years is longer than trees have existed, longer than animals have existed, longer even than the oxygen-rich air you are breathing right now. To touch a stromatolite is to touch a moment closer to the beginning of life than almost anything else we have. Isn't that astonishing? Picture the scene where stromatolites grew. Shallow seas stretched out under a younger sun, their waters tinted with dissolved minerals. Colonies of microbes, cyanobacteria, spread across rocks and tidal flats, capturing sunlight to make energy. Each day, as they thrived, they trapped grains of sediment. Layer upon layer built up, until mats became mounds, and mounds became towers. Slowly, patiently, these towers recorded the lives of the microbes within them, freezing their story in stone. And though the microbes themselves are gone, the patterns they left remain, waiting for someone billions of years later to look down and recognize them. When you imagine that, doesn't it feel like the stone is alive with memory? What makes stromatolites even more remarkable is their legacy. These tiny organisms, through photosynthesis, began releasing oxygen into the world. At first, that oxygen rusted iron in the oceans, staining the seas red. Later, it began to fill the atmosphere itself, changing the planet forever. Think about that. A fossilized mound, quiet and unassuming, is not just a relic of life, but a marker of the greatest transformation Earth has ever undergone. Without those microbes, without their patient work preserved in stone, the path to complex life, including us, might never have opened. It's easy to overlook such fossils because they don't look dramatic, but in their quiet way they hold the key to the entire story of evolution. Of course, stromatolites are not the only fossils from deep time. Scientists have also found what they call microfossils, tiny structures visible only under a microscope, embedded in ancient rocks. Some of these are the preserved shapes of single cells, no larger than a grain of dust. Others are clusters, resembling simple colonies. At first glance, they might look insignificant, like flecks or imperfections in the rock. But then you remember, each shape is a signal that life existed when the planet itself was still young. Isn't it incredible how something so small, almost invisible, can hold so much meaning? These are the ancestors of everything, the roots of the great tree of life, and yet they appear to us as barely more than a speck. And then there are chemical fossils, traces of molecules rather than bodies. Certain compounds, produced only by life, have been discovered in rocks billions of years old. They are not bones or shells, but chemical fingerprints, hints that life once thrived in places where no shape remains. To the untrained eye, a chemical fossil is nothing more than data, lines on a chart. But think of what it represents, the faint perfume of life caught in stone, still lingering after eons. It is as though the earth exhaled long ago and, impossibly, that breath can still be detected. Doesn't that invite you to see fossils differently, not only as physical objects, but as signals, delicate and mysterious, calling to us across time? There is a kind of humility in realizing how much of our understanding comes from these fragile clues. A fossil is rarely complete. It is partial, ambiguous, open to interpretation. That is why debates continue among scientists. Is this shape truly a microbe or just a quirk of mineral growth? Is this chemical signature really biological or the result of geology alone? The uncertainty can be frustrating, but it is also what keeps the story alive. Mystery makes us curious. It reminds us that the past is not a closed book, but a puzzle we are still learning to solve. Don't you find comfort in that the Earth still has secrets, that not everything has been explained away? Even with these mysteries, one truth shines through. Life, once it appeared, left marks. Those marks endured storms, shifting continents, volcanic eruptions, and ice ages, yet they are still here. That endurance is almost beyond comprehension. Think of your own life. A photograph can fade in decades, a building can crumble in centuries. But fossils last for millions, even billions of years. They are patience incarnate. Geology waits, quietly holding the stories of life until someone is ready to uncover them. There's something almost spiritual in that patience, isn't there? The idea that the earth keeps these memories safe, not in haste, but in silence and stone. Now, imagine yourself walking along a dry, ancient outcrop where the sun warms the rocks. You reach down, and in your palm lies a stromatolite, layered and worn. You are the first human to touch this particular stone, the first to feel its weight since it was formed. What you are holding is not just a rock. It is a direct line to life, as it was 3.5 billion years ago. Your heartbeat quickens, your thoughts quiet, and suddenly the vastness of time doesn't feel abstract. It feels personal. You are connected, not in theory but in reality, to life's first chapters. Isn't that a shift in perspective? To see yourself not as separate from the past, but as a continuation of it? The power of fossils is that they change the way we see ourselves. We often think of our lives as fragile, temporary, easily swept away. And in many ways, that's true. But fossils remind us that traces endure. Even the simplest microbes, unnoticed in their own time, left signals that outlasted entire mountain ranges. If such small beings could leave such a legacy, what does that suggest about us? Not in terms of bones turned to stone, but in the marks we leave on each other, on our communities, on the world. Fossils whisper that nothing is truly lost. The essence of life has a way of persisting. And perhaps that is why fossils inspire such awe. They are not just scientific data, they are symbols of resilience. They show us that life leaves echoes that stretch across unimaginable spans. They remind us that patience is not weakness, but strength, that endurance can be as powerful as brilliance. As you think about stromatolites, microfossils, and chemical traces, let them be more than curiosities. Let them be reminders that even the smallest act of living can ripple forward, leaving an imprint more enduring than you might ever guess. So the next time you see a fossil, whether it is a trilobite in a museum or a ripple of stone in a field, pause for a moment. Remember that you are not just looking at a rock. You are looking at a time capsule, a signal from a world so ancient it defies imagination. You are touching memory itself. And in that memory lies a message. Life is persistent, patient, and astonishingly creative. Even in its simplest forms, it knew how to leave a mark. And perhaps as you drift into rest tonight, that thought can comfort you, the knowledge that you, too, are part of that same story, leaving your own quiet signals behind. Imagine standing on the shores of an ancient earth, long before forests, animals, or even the simplest plants had appeared. The seas stretch wide, shimmering under a sun weaker than the one we know today, and the air above is thick with gases we could never survive breathing. It is a planet alive with activity, but not yet alive in the way we imagine. And then, in that alien ocean, something begins to stir. Tiny organisms, too small for the naked eye, float near the surface, catching sunlight. They are cyanobacteria, simple in form but powerful in potential. With quiet persistence, they begin performing a trick that would transform the entire planet: photosynthesis. Photosynthesis sounds so familiar now. Plants and algae do it every day around us, but when it first began, it was revolutionary. These small bacteria found a way to use sunlight to split water molecules and create energy, releasing oxygen as a byproduct. To us, oxygen is life itself, filling our lungs with each breath. But in that early world, oxygen was a poison. The creatures that already existed had evolved in an oxygen-free environment. They had no defenses against this strange, reactive gas. So what cyanobacteria offered was both a gift and a threat. The air itself was beginning to change, and life would never be the same again. Picture the effect: oceans gradually turning rusty red as oxygen reacted with iron dissolved in the water, forming massive deposits of iron oxide that still line the Earth's crust today. Imagine the atmosphere shifting, molecule by molecule, until it no longer resembled the air it once was. For countless anaerobic organisms, creatures that thrived in oxygen-free environments, this change was catastrophic. Many died out, unable to adapt. Entire lineages were wiped away, their long persistence undone by a change they could not survive. Can you feel the weight of that? Life creating its own apocalypse, reshaping the world so completely that its earlier inhabitants could no longer exist. And yet, within that destruction lay opportunity. Oxygen, though deadly for some, was a gift for others. Its presence made possible more efficient ways of producing energy. Organisms that could tolerate it, and later, that could embrace it, gained a tremendous advantage. Oxygen opened the door for complexity. Cells could grow larger, more intricate, able to support new functions and interactions. The world was no longer only for the small and the simple. The stage was being set for creatures with tissues, organs, and eventually bodies far larger and more elaborate than anything the Earth had ever seen. Isn't it remarkable that this turning point, this vast leap in potential, came from bacteria so small we cannot see them without magnification? Think about the contrast for a moment. On one hand, you have microscopic organisms floating in shallow seas. On the other, you have the fate of the entire planet shifting because of their activity. How could something so small change so much? That question is both scientific and personal. If cyanobacteria could alter the chemistry of the skies and oceans, what possibilities might exist in the small choices of our own lives? We often underestimate the impact of the tiny, tiny organisms, tiny actions, tiny beginnings. But history whispers otherwise. Even the smallest spark can change the course of everything. The transformation wasn't immediate. It unfolded over millions of years, patient and relentless. The atmosphere accumulated oxygen slowly, at first absorbed by rocks and oceans, then eventually spilling over into the air itself. Scientists call this moment the Great Oxygenation Event, and its consequences were profound. Not only did it bring extinction to many anaerobic species, but it also made the environment unstable, prone to shifts in climate. Some evidence even suggests the rise of oxygen contributed to global glaciations, the so-called snowball Earth episodes where ice may have reached nearly to the equator. Life was not simply building a world, it was reshaping it in cycles of creation and challenge. It's tempting to see this as cruel, the rise of one form of life spelling doom for another, but perhaps it's more honest to see it as transformation. Life is not static. It doesn't hold one shape forever. Instead, it changes its environment, and in doing so, it changes itself. The Great Oxygenation is proof that life isn't just a passenger on Earth. It's a force capable of rewriting the rules of the game. And from that rewriting came resilience, diversity, and new possibilities. Oxygen, once a toxin, became a promise. It made possible every breath you've ever taken, every thought your brain has sparked, every beat of your heart. Doesn't that give you a sense of awe? To realize that the air filling your lungs tonight is not simply a natural given, but the result of an ancient crisis overcome? It reminds us that survival often comes not by resisting change, but by adapting to it, even embracing it. The cyanobacteria did not plan for this transformation. They simply did what they could to thrive. And in their thriving, they remade the world. There is a lesson in that for us too. We can't always see the consequences of our actions, but sometimes the quiet, steady persistence of doing what we do best can create shifts larger than we imagine. Even now, you carry the legacy of that event within you. Your cells rely on oxygen to generate energy. Without it, you could not stand, think, or dream. Every inhale is a continuation of a process that began with microbes billions of years ago. Isn't it strange to think that your very life is tethered to theirs, that the rhythm of your breathing is a living echo of their ancient work? That connection across time is humbling, but also empowering. You are not separate from the story of the Earth's transformation. You are one of its results. So as you lie here listening, consider this. The Great Oxygenation was both catastrophe and opportunity. It ended worlds and opened new ones. It destroyed and it created. Life itself was the architect of this paradox, proving that even the smallest players can rewrite the rules of existence. Doesn't that thought invite you to see your own challenges differently? Change may feel destructive in the moment, but it can also hold the seeds of new beginnings. Just as oxygen turned poison into promise, your own struggles may one day prove to be the ground where something new can grow. And as we move forward in this story, keep in mind what this shift made possible. The rise of oxygen was not just a crisis, it was the prelude to complexity, to creatures larger and stranger than the world had ever seen. But for now, let the thought settle that the air around you, the breath within you, is not ordinary. It is the result of the smallest organisms rewriting the planet, leaving you the inheritance of possibility. That quiet, unseen power is still at work, reminding you that transformation is always closer than you think. Imagine a world where the ocean was quiet, a steady expanse of nothing much happening, a place that could lull you into a sense of endless calm. The sea stretched as far as the eye could imagine, uniform, gentle, almost predictable. And then, in a geological heartbeat, everything changed. Around 540 million years ago, life as it had been known underwent a radical, almost dreamlike transformation. Suddenly, the ocean floor became a stage for an astonishing parade of shapes, movements, and strategies. It was as if evolution, which had been quietly tinkering in the background for hundreds of millions of years, finally decided to reveal its hand. This was the Cambrian explosion, a time when the rules of biology were rewritten and the imagination of life itself seemed to run wild. Creatures appeared that no one had ever seen or could have predicted, and yet each one was a testament to the endless possibilities of form and function. Picture the Burgess Shale, nestled in the Canadian Rockies, as a snapshot of this transformation. Fossils embedded in its layers act as time capsules, whispering secrets from a world we can barely recognize. Here, the trilobites scuttled across the soft sediment with their segmented bodies glinting in the ancient sunlight, an early blueprint of armored life. They were familiar in a way, yet exotic, creatures with jointed limbs and faceted eyes that would have seemed like tiny mosaics capturing the light of a sun that shone over a world entirely their own. Watching them in the mind's eye, you sense both their strangeness and their undeniable presence. They were survivors in a realm suddenly bustling with new challenges and new competitors, and their very form tells a story of adaptation, endurance, and invention. And then there were creatures like Anomalocaris, a predator unlike anything we know today. Its name hints at its peculiarity, anomalous shrimp, a rough translation that barely captures the elegance and terror of its design. Imagine an elongated body, flexible yet armored, with a circular mouth rimmed with spiny teeth that could grasp and slice. Its eyes, mounted on stalks, seemed almost sentient, scanning the murky waters for movement, for opportunity. The presence of Anomalocaris transforms the ocean from a peaceful scene into a theater of tension, a place where every ripple might signal life or death. And yet, there is beauty in its strangeness. The lines of its body, the motion of its appendages, even the way it might have glided through water, evoke a kind of quiet wonder. It reminds us that evolution doesn't just solve problems, it experiments, invents, and dares to imagine forms of life that defy our expectations. And then there is Opabinia, perhaps the strangest of all. 5 eyes perched on stalks, a flexible proboscis ending in a claw, a body that seems segmented yet fluid. It is almost dreamlike, the kind of creature that seems more suited to a surreal painting than a real ecosystem. And yet, there it is, fossilized, a record of a mind-boggling reality. When you look at Opabinia, you are confronted with the limits of your imagination, forced to consider that life's possibilities are far broader than what your senses have ever experienced. There is a subtle thrill in this encounter, a mixture of delight and mild disorientation, as though you are peeking into a world that obeys different rules, a world where creativity is not optional but essential for survival. It challenges your assumptions about what an animal can be, and it invites you to marvel at the sheer inventiveness of life. These creatures are more than fossils. They are signals, whispers from a deep past that still resonates today. Their bodies, preserved in shale, suggest a sea suddenly alive in ways the Earth had never seen before. Imagine a quiet seabed that had been unchanging for millions of years, and then, as if a switch were flipped, it teemed with motion, with hunting, with hiding, with strange dances of survival. There is a rhythm to the scene, a pulse that communicates urgency and curiosity. Each creature is a story, a strategy, a way of existing that had never existed before and may never exist again. You can almost hear the subtle shuffling of limbs, the brushing of segmented bodies against soft sediment, the silent strikes of appendages reaching for prey. There is an intimacy here, a reminder that even in a world so alien, the core dramas of life, searching, surviving, thriving, remain the same. The Burgess Shale and its contemporaries are also a lesson in perspective. They remind us how fragile our sense of normal can be. We look at life today and think we understand its limits, but the Cambrian period proves otherwise. Nature is not static, it is a constant experimenter. When you confront fossils like these, you are invited to step outside your identity as a modern observer and imagine yourself as part of an ancient ecosystem, where the familiar rules of biology are suspended and replaced with radical innovation. There is a thrill in this shift, a subtle empowerment, because it asks you to reconsider what is possible. The world you know, the animals you see every day, are just one chapter in a story that stretches back further and is far stranger than your mind can usually accommodate. Consider the patterns and textures revealed in these fossils. Trilobites' segmented carapaces glint like tiny armor suits, each articulation a marvel of functional design. Anomalocaris' circular mouth is both terrifying and elegant, like a natural puzzle of precision engineering. Opabinia's proboscis and multiple eyes create a visual language that seems to say, "Look closer. There is more here than you think." These are not just forms, they are adaptations, answers to survival pressures, and a testament to the imagination inherent in natural selection. There is almost an ASMR quality in contemplating the lines and shapes of these creatures, a soothing fascination that draws you in, urging you to linger over each detail, to imagine the living, moving animal rather than the frozen fossil. The effect is quietly mesmerizing, a gentle immersion into a world both alien and familiar, strange yet intimate. And yet, there is something profoundly emotional about this encounter. These creatures, extinct as they are, provoke a sense of connection. They lived, hunted, and evolved, just as we do, and their stories, written in stone, echo across eons. You can feel the tension of survival in Anomalocaris' predatory glide, the cautious navigation of trilobites across the seafloor, the almost whimsical mystery of Opabinia's multi-eyed gaze. There is empathy here, a subtle identification with life that refuses simplicity. In contemplating these creatures, you are reminded of your own place in the web of existence, the fragility and brilliance of life, and the deep currents of change that have shaped every living thing. The Cambrian explosion is not just an event, it is a mirror held up to the endless creativity of life, and to our own fleeting yet meaningful presence within it. The surprise and novelty of these forms cannot be overstated. For hundreds of millions of years, life had remained relatively simple, dominated by soft-bodied organisms that left few traces. Then, almost abruptly, a dazzling variety of body plans emerges: spines, segments, stalked eyes, flexible appendages, and armor. The sheer audacity of this biological experiment is both humbling and exhilarating. It reminds us that evolution has no blueprint, no master plan, only the relentless drive to explore possibility. The Cambrian seas were laboratories of invention, and the Burgess Shale fossils are the records of its experiments. Each creature is a lesson in daring, a reminder that creativity is not a human monopoly, but a fundamental feature of life itself. And this realization can shift your perspective, making the familiar world around you seem full of latent potential, waiting for discovery. Think about the quiet suspense in witnessing this explosion of life. Before, the ocean floor was a place of stillness. Now it is teeming with interaction, with tension, with the push and pull of predator and prey, innovation and survival. There is a rhythm, almost musical, to the movements and strategies of these ancient beings, and in observing it, we are invited to slow down, to absorb, to imagine. We feel the subtle fear and exhilaration that these creatures must have felt, navigating an environment that is both dangerous and rich with opportunity. It is a reminder that curiosity and caution, exploration and preservation are timeless drivers of life. There is power in recognizing these patterns, a quiet empowerment that comes from understanding the deep continuity of experience, even across hundreds of millions of years. The more you look, the more the oddities of these animals become familiar, almost comforting. Their strangeness gradually reveals underlying principles: segmentation, sensory specialization, locomotion strategies. You begin to see not just what is different, but what is shared across life's tapestry. This duality, strangeness and familiarity, is a profound psychological trigger. It draws you in, engaging both your sense of novelty and your desire for understanding. You feel the thrill of discovery, the pleasure of pattern recognition, and the subtle shift in identity that comes from seeing the world through the eyes of a Cambrian observer. In this way, the Burgess Shale becomes not just a fossil site, but a classroom, a mirror, and a meditation on the inventive power of life itself. Every fossil carries a story of change, risk, and adaptation. Trilobites tell of armored exploration, Anomalocaris of relentless predation, Opabinia of curious experimentation. They each represent paths chosen by evolution, roads not taken by other organisms, possibilities that were realized in a specific context and then frozen in time. Contemplating them, you sense the vastness of life's canvas, the scale of time, and the beauty of forms that no longer exist. There is a gentle awe in this realization, a feeling that life is larger, stranger, and more inventive than our everyday experience allows. And with that awe comes reflection. If life could be this creative before, what might it achieve next? And how does that potential ripple into the present, into our own lives and choices? The Cambrian explosion is a reminder that the world is full of surprises, that evolution is not linear but experimental, that the creatures we know today are just one outcome of countless possibilities. It urges us to embrace curiosity, to look beyond the familiar, and to appreciate the courage inherent in every act of adaptation. As you imagine the trilobites scuttling, the Anomalocaris gliding, and Opabinia exploring with its 5 eyes, you feel a connection that is both intellectual and emotional. You are witnessing life's audacity, and in doing so, you are invited to consider your own capacity for creativity, resilience, and transformation. The past becomes a mirror for possibility, a reminder that existence is an ongoing adventure filled with mystery, risk, and profound beauty. Even in their stillness, fossils have a voice. They speak of innovation, of survival, of a world that embraced complexity without fear. They invite reflection on the fragility of ecosystems and the resilience of life. They provoke the mind to question assumptions, to marvel at forms that challenge imagination, and to appreciate the subtle poetry of existence. Looking at them, you are both observer and participant, drawn into a narrative that spans hundreds of millions of years yet resonates deeply in the present. There is a quiet intimacy here, a sense that in studying these creatures, you are not just learning about the past, you are rediscovering the richness of possibility in your own world. The Cambrian seas, once silent, are suddenly alive with motion, conflict, and curiosity. They teach that life's creativity is unbounded, that strangeness and beauty coexist, that survival is both a challenge and an art form. The Burgess Shale fossils are portals, windows into this astonishing reality. Through them, we glimpse the wonder of innovation, the thrill of novelty, and the persistent drama of existence. They remind us that life is never static, that every moment is a chance for transformation, and that even the smallest creature carries within it the story of experimentation, adaptation, and survival. To encounter these fossils is to feel both humility and inspiration, a sense of connection to a world that is at once alien and deeply familiar. And so, as you contemplate the Cambrian explosion, the strange creatures, and the dynamic seas, there is an invitation to see beyond the familiar, to embrace the wonder of possibility, to recognize that life is a continuous unfolding of creativity. The trilobites, Anomalocaris, and Opabinia are not just fossils. They are teachers, provocateurs, and companions across time. They remind us that the universe of life is vast, intricate, and endlessly inventive. They invite you to pause, to imagine, and to marvel. And in that pause, in that act of seeing, there is a subtle transformation, a shift in perspective, an expansion of identity, a gentle empowerment that comes from connecting with a world at once distant and intimately relevant. The Cambrian explosion is more than history. It is a living story, echoing in every heartbeat, whispering the infinite potential of life. After the wild imagination of the Cambrian seas, life did not simply settle into quiet predictability. Instead, it continued to explore, to diversify, and to leave traces that would one day tell its story. Fossils, once tiny imprints of strange creatures, gradually evolved into forms more familiar to our eyes. Imagine walking along a shoreline millions of years after the Cambrian, where delicate shells glint under sunlight, plants press against sedimentary layers like careful scribbles in an ancient journal, and fish, their bones perfectly preserved, suggest movements frozen in time. These remnants form a bridge between the unrecognizable oddities of early life and the creatures we know more intimately, reptiles, amphibians, and eventually the dinosaurs that once roamed the earth with power and elegance. Each fossil is a signal, a whisper from the past, and together they create a continuity that is both comforting and astonishing. They remind us that life, in all its forms, has been writing its own story long before we arrived to read it. Fossils act as chapters in a vast, unfolding narrative. Imagine the Earth as a library, each layer of rock a page, each stratum a paragraph filled with detail and nuance. Paleontologists approach these layers with reverence, knowing that patience and careful observation reveal the richness of a story stretching back hundreds of millions of years. Consider a simple shell embedded in limestone. It may seem small, even mundane, yet it carries information about the environment in which it lived, the temperature of the water, the chemistry of the ocean, and the ecological relationships that shaped its life. Moving up through layers, we encounter more complex organisms, fish with spiny fins gliding through ancient rivers, plants pushing towards sunlight in newly formed forests, and reptiles navigating a land teeming with competition and opportunity. Each fossil is a guidepost, marking a transition, a change in the evolutionary storyline that reminds us of the persistence and creativity inherent in life. Reading these layers is both science and art. Paleontologists use tools that allow them to place fossils in time, the position within strata, the relative thickness of sediment, and radiometric dating that measures isotopes decaying at precise rates. This combination of observation and calculation creates a temporal map, a way of understanding not just the shape of life, but its rhythm across eons. It is easy to feel disconnected from such vast scales, yet the fossils themselves anchor us, grounding abstract numbers in tangible forms. When you hold a fossil, you touch patience, a reminder that life's story does not rush. It waits, layer by layer, patiently encoding details for those willing to look. There is comfort in this continuity, a sense that despite the chaos and unpredictability of life, there is also order, a narrative unfolding with surprising clarity if we are attentive enough to perceive it. Consider the elegance of transition in the fossil record. From delicate shells to coral formations, life moves from the ocean to the land, a migration that rewrites the rules of survival. Fish, once confined to water, gradually evolve into amphibians, exploring both water and land, leaving footprints in mud that would one day fossilize into eternal evidence. Reptiles follow, building skeletons capable of supporting bodies against gravity's pull, adapting to environments both harsh and varied. Each step is recorded in stone, a series of experiments in form, function, and survival. The fossils do not merely tell us that these creatures existed, they teach us about adaptation, resilience, and the subtle pressures that shape life. We begin to see continuity as a narrative device. Each layer is a sentence, each fossil a word, together forming an epic that stretches far beyond human memory or imagination. Then there are the dinosaurs, whose bones dominate imagination as much as they do the fossil record. Their size and diversity provoke awe, yet their presence in rock layers also emphasizes continuity. Before the giants, smaller reptiles paved the way, testing strategies of locomotion, diet, and defense. The dinosaur fossils tell a story of experimentation and success over tens of millions of years, and their extinction, recorded in subsequent layers, reminds us of the fragility inherent in even the most formidable life forms. Holding a dinosaur bone, even a fragment, connects you to this continuity. You feel the weight of history, the relentless passage of time, and the triumph of life's persistence, its ability to diversify, adapt, and leave enduring traces. There is empowerment in this understanding. The past is not alien, but instructive, offering lessons on resilience and the beauty of persistence. Fossils also teach us to notice detail. Imagine a paleontologist brushing away sediment from a delicate fern imprint. The lines of the leaves, the faint trace of veins, the curvature of the stem, all convey information about the climate, the environment, and the plant's role in its ecosystem. Similar care reveals tiny fish fossils, where fin rays, scales, and skulls provide insight into the development of vertebrates. Each careful observation is a revelation, transforming a fragment of stone into a narrative that spans landscapes and eras. The continuity here is profound. From the earliest shells to the largest dinosaurs, every fossil contributes a sentence to life's ongoing story. In learning to read it, we participate in an ancient dialogue, connecting across time, guided by patience and curiosity. The psychological impact of this continuity is subtle yet powerful. Fossils remind us that life is persistent, creative, and patient. They counter the anxiety of fleeting existence, showing that individual lives, though transient, are part of a much larger story that endures. There is reassurance in understanding that adaptation, exploration, and survival are not random acts, but part of a rhythm stretching back to the earliest life forms. Each layer of rock and each fossil it contains becomes a meditation on time, a prompt to reflect on the resilience inherent in natural processes. In this sense, fossils are teachers, offering guidance, patience, and a profound perspective on our own lives as we navigate challenges, change, and growth. Consider the wonder of discovery itself. When a paleontologist uncovers a new fossil, it is not merely a scientific achievement, but a narrative revelation. Each finding illuminates a chapter that may have been obscured for millions of years. The excitement lies not just in the object, but in the story it reveals. A fish caught mid-swim, a fern pressed against sediment, a reptile frozen in a moment of struggle or repose. This is continuity in action. Past life leaves traces, which then guide future understanding, creating a chain of knowledge and connection. For the observer, there is both FOMO and exhilaration, the knowledge that countless stories lie hidden, waiting to be found, and the recognition that even the smallest discovery can shift understanding profoundly. Fossils also shape identity. When we study them, we adopt a mindset attuned to both patience and curiosity, to seeing the extraordinary in the ordinary, and to respecting the intricate rhythms of time. Each fossil teaches perspective, showing how minor changes accumulate over eons, leading to dramatic transformations. The layers of sediment become a mirror, reflecting the continuity of life and the patterns that underlie it. Recognizing these patterns can shift how we view our own existence. Each moment, each choice, contributes to a larger narrative, just as each creature contributes to the story preserved in rock. There is subtle empowerment in this realization, a reminder that while individuals are fleeting, the arc of life itself endures, vibrant and endlessly inventive. Even everyday fossils, those small shells or leaf imprints, carry weight. They provide continuity between ancient oceans and our modern world. A shell fossil might seem insignificant until you consider it alongside millions of others, forming a pattern of biodiversity, climate, and geological change. Each specimen becomes part of a tapestry, connecting past and present, teaching us to notice relationships, dependencies, and shifts over time. This approach to observation, careful, reflective, attuned to detail, mirrors how we can approach our own lives, making choices with awareness of consequence and appreciation for continuity. Fossils thus act as mentors, guiding both knowledge and behavior, revealing how life persists, adapts, and thrives despite obstacles and unpredictability. Reading fossil layers is like reading a diary written over eons. Each entry is a snapshot of existence, and each fossil a character in a drama of survival. In this sense, paleontology is not merely science, but empathy, imagination, and interpretation. We reconstruct ecosystems, behaviors, and interactions, filling gaps with evidence and reasoned inference. This process engages the mind and the emotions, creating a vivid, almost tactile connection with life that no longer exists. The continuity is both chronological and thematic. Change is gradual, yet each new layer brings surprises, innovations, and reminders of life's resilience. In following these threads, we gain insight not just into the past, but into the principles that govern persistence, adaptation, and creativity today. The patient narrative of fossils contrasts sharply with the human pace of life. Where we rush, fossils endure. Where we struggle to comprehend decades, they whisper across millions of years. There is a quiet empowerment in realizing that the story continues, that life is not bound by immediate pressures alone. Each shell, each bone, each imprint is a signal that existence has its rhythms, and that understanding comes with observation, patience, and reflection. The continuity in these layers reassures us that life adapts and persists, that complexity emerges naturally, and that survival is a product of both change and consistency. Fossils invite us to step outside our temporal perspective, to see ourselves as part of an ongoing story much larger than individual experience. As we trace the arc from tiny shells to dinosaur bones, the continuity of life becomes tangible. The narrative flows through layers of rock, each one distinct yet inseparable from the last. We observe adaptations, innovations, and extinctions, each contributing to an ever-evolving story. Paleontologists, like careful readers, interpret these signs, reconstructing environments, diets, and behaviors. The result is not only scientific knowledge, but a profound psychological insight that life is persistent, resourceful, and endlessly inventive. Fossils offer both comfort and awe, anchoring us in the long narrative of life while inspiring reflection on our own place within it. Every fossil, from the simplest shell to the largest dinosaur bone, contributes to a collective memory of life. They teach continuity, resilience, and creativity. They allow us to read history not as abstract dates, but as living stories encoded in stone. The layers become a classroom, the fossils teachers, and the act of study transforms observer and subject alike. There is empowerment in this process, an intimacy with life across time, and a gentle reassurance that the arc of existence, though punctuated by challenges and extinction, carries forward, rich with innovation and connection. In contemplating these fossils, we are reminded that life's narrative is patient, continuous, and profoundly instructive, waiting for us to listen and learn. As we move through the layers of time, it becomes clear that fossils are more than remnants of creatures long gone. They are teachers, patient and enduring, whispering lessons about resilience, extinction, and adaptability. Each fossil is a testament to survival across unimaginable spans of time, but it is also a record of loss. The species that thrived, the ones that stumbled, the moments when ecosystems shifted, all of it is etched into stone. When we hold or observe a fossil, we are in touch with both triumph and fragility. There is a quiet wisdom here, one that asks us to consider not only the persistence of life, but its impermanence, and in doing so, it mirrors our own existence. Life is both strong and fleeting, and fossils encapsulate this paradox in ways that words alone cannot convey. Consider the delicate curves of a seashell pressed into sediment. Its form speaks of survival in its own environment, how it resisted currents, how it protected its soft interior, how it reproduced to carry on its line. Yet the shell is also a silent witness to the fragility of life. Somewhere along the chain, conditions shifted, species vanished, and the world transformed. Fossils teach us that adaptability matters, that even the strongest forms are subject to change, and that resilience is not merely a matter of strength, but of timing, opportunity, and subtle responsiveness to a shifting environment. In this sense, fossils are mentors from deep time. They demonstrate that the ability to endure is coupled with the ability to transform, and that extinction, while natural, leaves traces that continue to inform and inspire. There is something profoundly humbling in the scale of this perspective. Looking at a fossil, we are reminded that our own lives are but brief chapters in the endless story of life. Yet this brevity does not diminish meaning, it enhances it. When we realize that every birdsong, every seashell, every ripple of stone is connected to an ancient lineage, we begin to perceive continuity and presence in a new way. A leaf fossil from millions of years ago, lying silently in rock, is linked to the green trees we walk beneath today. A trilobite imprint is echoed in the rhythms of our oceans, the currents and tides that shape our world. Fossils provide a bridge across time, connecting the smallest gestures of life to the vastness of history, offering both awe and intimacy. They remind us that our lives, while fleeting, participate in a narrative far larger than ourselves. Fossils are also mirrors of change. They reveal the world as it was and as it is no longer, showing us the processes that have shaped the planet. Through them, we learn that extinction is not merely an abstract concept, it is a force that has repeatedly reshaped life. Mass extinctions wiped out entire lineages, yet from these losses came opportunities for new forms to emerge. Mammals, birds, and flowering plants thrived in the aftermath of catastrophic events, just as humans have adapted to changing environments over millennia. Observing this interplay between loss and renewal allows us to approach our own challenges with perspective. We recognize that adaptability is not optional and that resilience often requires an openness to change, a willingness to explore new paths even when the familiar world is no longer viable. There is a subtle intimacy in understanding this. Fossils, patient as they are, do not demand attention, they invite it. A slab of rock may hold countless secrets, each waiting for discovery. In unearthing a fossil, the paleontologist or the curious observer engages in a conversation with time itself. Every scratch, every curve, every pattern tells a story of survival, of environment, and of relationship. You begin to sense that the earth itself is a repository of memory, each stone a potential storyteller, and that the act of observation is not merely academic, but profoundly connective. There is a rhythm here, a cadence in the unfolding of life, that resonates with the quiet heartbeat of our own existence, inviting reflection, empathy, and understanding. The lessons of fossils extend beyond science. They reach into how we relate to our environment and to each other. Understanding the fragility of life across eons fosters a sense of care and responsibility. When we recognize that even the most seemingly permanent species can disappear, we approach our world with reverence, aware that our actions ripple outward, influencing ecosystems and the survival of countless lives. Fossils remind us that life is interwoven, each form dependent on others in subtle, intricate ways. There is empowerment in this awareness. By understanding continuity and connection, we can make choices that honor the past, sustain the present, and shape the future. In listening to fossils, we are guided toward empathy, patience, and a respect for the delicate balance that sustains life. There is also comfort in the patience that fossils embody. Unlike us, they do not hurry, and their narratives unfold across millions of years. This patient storytelling contrasts with our fast-paced lives, where we are often anxious for immediate results or instant understanding. Fossils teach us that observation and reflection are profound forms of engagement, that meaning emerges gradually, and that time itself is a teacher. In this gentle contrast, there is a soothing quality, a reminder that the world is larger than our immediate concerns and that life has endured, adapted, and persisted long before we appeared. The continuity of life offers reassurance. We are part of a grand story, a lineage of change and survival that continues to unfold in ways both subtle and magnificent. Every stone has the potential to be a teacher. Beneath the surface, fossils wait quietly, carrying memories of creatures, ecosystems, and events that shaped the planet. Their presence asks us to slow down, to look closer, to consider that beneath our feet lies evidence of extraordinary processes. Even the most ordinary rock might conceal a fragment of life that endured through heat, pressure, and shifting landscapes. This possibility, that discovery is always within reach, ignites a quiet curiosity. It encourages mindfulness, a sense of wonder, and the understanding that the world is layered with stories. Fossils invite us to be attentive, patient, and reflective, transforming everyday observation into a connection with deep time. Reflecting on this connection brings a sense of perspective. Our lives, with all their daily routines, challenges, and joys, are framed within a much larger continuum. We are both small and significant, fleeting and meaningful. Fossils remind us of our temporal position, yet they also affirm that each action, each thought, and each choice contributes to a lineage of existence. The continuity of life encourages a sense of stewardship and belonging. It reassures us that even in the face of change, of uncertainty, and of eventual loss, our lives intersect with a vast narrative, one that stretches across eons and will continue long after our own moments have passed. There is solace and quiet pride in this realization, a recognition that life's story includes us in ways both subtle and profound. Consider the emotional resonance of witnessing a fossil for the first time. There is an almost meditative quality in tracing its contours, imagining the environment in which it lived, the creatures it interacted with, and the world it once inhabited. A fossil can evoke awe, curiosity, and a gentle melancholy, a mix of admiration for survival and acknowledgement of impermanence. This emotional depth is part of why fossils remain so compelling. They are not static objects, but invitations to reflect, to empathize, and to imagine. They offer a personal connection to history, a bridge from deep time to the present moment, and a reminder that every layer of the earth contains evidence of persistence, creativity, and adaptation. In understanding fossils, we also recognize the unity of life. The bones, shells, and imprints link past ecosystems to present ones, tracing threads of continuity that reach across species, continents, and eras. Every birdsong, every seashell, every ripple of stone is a trace of this endless story. Fossils allow us to witness patterns repeated, lessons learned, and adaptations honed. In this way, they are not merely artifacts of science, they are companions in reflection, reminders of the creativity and resilience inherent in life. Engaging with fossils becomes an act of empathy, a recognition that the present is inseparable from the past, and that our understanding of existence is enriched by observing the traces left by others who came before us. As we conclude this journey, it is worth pausing to let the images settle. Picture a fossil quietly embedded in rock, a silent witness to millions of years. Consider the persistence, fragility, and adaptability it represents. Reflect on your own life, your challenges, and the choices you make, knowing that you are part of a continuum that stretches far beyond your immediate perception. Allow this awareness to bring comfort and perspective. Let it remind you that while life is fleeting, it is also deeply connected, layered with meaning and resilient beyond measure. Fossils offer both solace and inspiration, a quiet grounding in the vastness of existence. Finally, as you settle into your own space, perhaps preparing for rest, let the imagery of fossils guide a gentle landing. Envision the ancient seas, the forests, the shifting landscapes that cradled life across eons. Imagine every shell, every bone, every leaf imprint as a whisper from the past, connecting you to deep time and to the resilience inherent in life. Feel the continuity, the patience, and the quiet wisdom embedded in stone. Know that these lessons are always accessible, waiting in every rock, every sediment, and every trace of life. As you exhale and allow this sense of connection to wash over you, carry with you both calm and wonder, a gentle appreciation for the vast, enduring story in which you are a part. Thank you for joining this exploration. May you carry the patience and insight of fossils into your own life, allowing their continuity to offer perspective, comfort, and reflection. As you rest, remember that every moment, like every layer of rock, contributes to a greater narrative. If you,